Okay, so question 4, it's a fairly standard, just plug the numbers in type of question, provided you got the right formulas. And so the formulas we're looking for are these two on your formula sheet. So the best way to approach a question like this is just start working out some values. Notice that they've told us what the integral is here. So they've told us to integrate this term, you're going to end up with this result. So we don't have to worry too much. So we can find we could start off with the big R term. Can you recall what the R bar term is? Well, that's in effect like the neutral axis. So I would probably start there. That's the easy one to do. So the sum of the section and its R centroid location, like the Y centroid, sum of A's underneath. Right, so for the lower section here, we can see that we need to know what the distance is from here to where the center for the lower section is. So, well, let's start off with its area. So its area's got a 15 millimeters, a depth of 150. What's this RC? Well, it's going to be 400 plus half this distance from here to here, so that will be half of 150, 75, so 475. Right, now for the top section there, so to get from here to the middle of this section, well, let's put that in a minute. First, let's put in its area, so it's a width of 100. Its depth is 20. It's going to be 400 plus the lower section, which will be plus 150. Plus the half the height of the top section, which is 20, half of that will be plus 10. So that will be 560. Divide that all by 15 and the areas. 15 times 150 plus 100 times 20 and I found that to be 515 millimeters. So that's my R bar. My big R. Right, so for that, let's rearrange this formula. So we get R equals, that's going to give me A divided by 1 over R integrated with respect to A. And that term there I can find using the question. So we've got A notice we've got these two sections here, so we're going to have two integrals to do. So I've got B1 natural log R2 over R1 which would be for the lower section plus B2 natural log R3 over R2. So where the hell am I getting all these terms from? Well, the B, so what I'm doing is I'm doing this integral from here to here. So I've got two B's. I've got the first B, so come up through the integral, and that would be my B1. And then I've got my second B, which I go through this bit of the integral. The R1 will be at that location. The R2 will be the end of that block. And then the R3 will be the top of that block. So put all those values in. And you get the area. You can do that by using the lower section here. So I'm working in millimeters. So my lower section is 15 millimeters. So the R is the distance from here to here, so it's the total distance. Don't get confused. R1 doesn't start at 0. R0 is there, so we've got R1 is going to be 400 millimeters. So if it's 400 millimeters to here, we need to add on another 150. So that makes it 550 millimeters to there. Okay, for the top section, 100 natural log. So that is going to start at 550. And we need to add on another 20, so you get 570. Put that all in, and I got 509.07. And you certainly expect these two numbers to be similar. Your E, find your little E value here. Notice the way it's written, you expect that to be positive, and we're certainly going to get that. So 515 take away 509. Again, these are of course going to be in millimeters. So I think we've got all the terms that we will want to apply one of these equations to find the stress. We're going to use this one. So our bending stress is 900. the R, what am I doing there? So I'm going to be looking for the maximum R, which assumably will be the base, because that'd be the furthest R away. To turn the stress up. Oh, sorry, no, it's actually telling me where it wants it. So point C. Okay, so point C is 400 plus 150, it looks like to me, so it's this location here. So 400, so that's going to be 550. Take away the big R. Okay, I'm a little worried. My solution doesn't look correct. If I've done something wrong. Working in millimeters there, so let's put them in. The area, so that's going to be 4 to 50. Times 10 to the minus 6. .93 times 10 to the minus 3. And my little r is, I think, 550 times 10 to the minus 3. So what value do I get that? So I've got 900 times 500, take away 509. Okay, divided by 4 to 50 to minus 6 times 5.93 to minus 3 times 550 to the minus 3. And I don't get the right answer. What have I done wrong? Okay, I can't see where I've gone wrong, so I'm just going to try. Must have done a calculator mistake. 900. 550 take away 509.07, close my bracket, divide that by 1000. Ooh, that was different. Divided by 4250 minus 6 times 5.93 times. I've made a mistake on the calculator. Times 550 to minus 3. Oh, yes, now I get a sensible answer. Okay, so we've got 2.66 times 10 to the 6 pascals. So that's going to be B. Okay,